Alright, in this video we're going to learn about inverse trigonometric ratios. Okay, we have learned about tangent, sine, and cosine. Alright, and that how they mean the sine of an angle is the opposite leg over the hypotenuse, cosine is the adjacent leg over the hypotenuse, and tangent is the opposite leg over the adjacent leg. But what about these inverse trigonometric functions? Inverse trig functions are used to find unknown angles. Alright, so far we've been finding unknown sides. But what if we know the sides? For example, what if I know that this is 3 and this is 5? Okay, what I want to know is the angle. Okay, for angles we often use this variable. This is the Greek letter theta. Alright, and it's very traditional to use this variable for angles instead of using x's and y's and such. So let's begin to get comfortable with that. We're going to see that a lot more often. Theta, it's spelled like this. Okay, now the question is, how can I find theta? How can I find what this angle is? And here's the deal. We ask ourselves, well, which one of the three trigonometric ratios is happening here? From the perspective of this angle, this leg, is it opposite or adjacent? Well, it is adjacent because adjacent means right next to, and this leg is right next to theta. Of course, this side of the triangle is the hypotenuse, alright, no matter what. So, from the perspective of this angle, we're dealing with the adjacent leg and the hypotenuse. So we ask ourselves, which one of these three ratios involves the adjacent leg and the hypotenuse? And of course, that's the cosine function. The cosine of an angle is the adjacent leg over the hypotenuse. Okay, so fine. That means that the cosine of angle theta, alright, equals the adjacent leg over the hypotenuse, which in this case is 3 over 5. Now, we can use this to figure out what angle theta is, because it turns out if the cosine of angle theta is equal to 3/5, then angle theta is going to equal the inverse cosine of 3/5. What? Well, this is just a new function that will tell you the angle if you want it. And it's right on your calculator, okay, on your TI-30XS multi-view, which I just lost. Stand by. Okay, it's right on your calculator. If you look carefully, it's above the sine, cosine, and tangent. You see that little sine with a little -1 on it, and the cosine. That's inverse sine, inverse cosine, and inverse tangent. Alright, so if I want to know, if I want the inverse cosine of 3/5, okay, then I can hit second cosine. Alright, that's the inverse cosine. And now I can just do my 3/5. Okay, so that it tells me 53.1, I'll round to the nearest tenth. This is 53.1 degrees. Okay, so again, it's telling me the angle, 53.1 degrees. So, if you take one thing away from today's lesson, here it is. Inverse trig functions tell you the angle. If you want to find the angle, what do? You use inverse trig functions. Okay, now with that in mind, let's get to the actual lesson. So look at number 7. Our goal is to solve the triangle, so we want to find all missing sides and missing angles. As soon as I notice that neither one of these angles is given, if I'm going to find these angles, I'm going to have to use inverse trig functions. And because that's the main thing I want to teach you today, I'm going to actually do that first. I'll come back to AC, which we've already learned how to do in previous lessons. Let's find out, how do we find angle B? How do we find this guy right here? Well, first we have to figure out which trig function we are dealing with. So from the perspective of angle B, we need to know what are these two things, all right, the two numbers that we're given. One of these is the hypotenuse. Which one is it? Yeah, clearly that's the 5. So no matter what, 5 is the hypotenuse, so we're dealing with that. Now this 4, is this the opposite leg or the adjacent leg? Well, it is adjacent because that means right next to, alright? This is the leg that's close to angle B. Alright, so we have the adjacent leg and the hypotenuse. Which trig function is that? Well, cosine. The cosine of an angle is the adjacent leg over the hypotenuse. So since we got adjacent and hypotenuse, that tells us that we need to use the cosine function. Okay? So that's what we'll do. So we'll set it up and we'll say the cosine of angle B is equal to the adjacent leg over the hypotenuse. So that's 4 over 5. Okay? So if I want to find the angle, I need inverse trig function. So that means that angle B is going to equal the inverse cosine of 4 over 5. Okay, so let's do that and we'll find angle B. Okay, so again, to do the inverse cosine, I'll have to hit second cosine, alright? By the way, make sure that your calculator is in degree mode. There's another mode that's RAD, radian mode. We don't want that right now. Okay, so we'll do 4 over 5. Okay, and for now, let's see, did the directions say what we're supposed to be rounding to? Nearest hundredth, so that means 2 decimal places. Well, it says length to nearest. Okay, angle measures to the nearest degree, actually. Okay, so we're going to round to a whole number here. Okay, so to the nearest degree, this would be 37 degrees. Well, we're rounding this up because of the 0.8. Okay, so that means angle B is approximately 37 degrees. Yeah. Alright, and that's how we do that. Now, once we find one angle, we do not need to use inverse trig functions to find the other angle. Alright, if this angle is 37 degrees, okay, these two angles together have to add up to 90. Alright, because that way all three angles will add up to 180 degrees. So once we have one angle, we will find the other angle simply by subtracting from 90. So this angle we will find by doing 90 degrees minus 37 degrees. Okay? Okay, so that's 53 degrees. Okay, so that's angle C is 53 degrees. Okay, so we really only needed inverse trig functions to find that that first angle. Now, I skipped over AC for a minute because that's old news, but let's go back and do it now. Finding AC is just the Pythagorean theorem. Okay, we have two sides of a triangle given. If we want to find the third side, it's the good old a squared plus b squared equals c squared. Okay, so let's do our Pythagorean theorem. So remember, the hypotenuse is our c squared. Okay, so so if this was x, then we're talking about 4 squared plus x squared is equal to 5 squared. Okay, so this is going to be 16 plus x squared is equal to 25. If you subtract 16 from both sides, alright, then you get x squared is equal to 9, and then if you take the square root of both sides, then you will get x equals 3. Okay, so that tells us that AC here is 3. Okay, and by the way, I mean, that's so common, a 3, 4, 5 triangle, that's actually worth memorizing. Alright, let's do another one. Number 8. Number 8, we actually do not need inverse trig functions to solve it, and it would be kind of silly to do so. So I'm not going to do that. We really only need the inverse trig functions when neither one of the angles are given. So I want you to get into the habit of, if you see one angle, I want you to find the other angle immediately by subtracting from 90. Okay? And that only works because we already have 90 here, so that means these two have to make 90. Because 90 plus 90 equals 180. So anyway, I'm just doing 90 minus 51. So that's going to be 39. Okay. So that's angle D that we found immediately is 39 degrees. All right. Now, how about finding these other things? All right, so if I want to find DE, for example, okay, DE is this right here. Okay. Now let's focus on let's continue to use the angle that they gave us at first instead of using the angle that we found. All right, just in case we subtracted wrong. Okay, we don't want to make two mistakes. So let's use the 51 and let's use the 18 feet, and we're trying to find x. So looking at these three things, which trig function are we dealing with? Well, let's see. 18 is the hypotenuse, of course. And from the perspective of the 51, DE over here is opposite. Okay, because it's across from. So opposite and hypotenuse. Which function is that? That is the sine function, opposite leg over hypotenuse. So that tells us that we're going to be using the sine function. Okay, so let's set it up. Sine of angle 51 is equal to the opposite leg over the hypotenuse. So that's x over 18. So we just need to solve for x here. Okay. So I can do that by multiplying both sides by 18. Okay, so that's going to give me 18 sine 51 is equal to x. Okay, so I can just now put that in my calculator and round to the nearest hundredth, 2 decimal places. Okay, so 18 sine 51. Alright, so that's 13.99. Got to round it up because of that. So DE is 13.99 feet. All right, I see the units here. Okay, now let's find EF. Okay, now that we know that DE is 13.99, technically I could find EF using the Pythagorean theorem, but I recommend not doing that, just in case we in case we made a mistake and it's wrong. Okay, so now we want to find EF. All right, EF is this side right here. Okay, and of course I still recommend we deal with the 51 degrees. So and we still got the 18 over here. All right, so this is what we're dealing with. Of course, the 18 still is the hypotenuse. All right, that's not changing. Now, this EF, is this the adjacent leg or the opposite leg? Well, this is the adjacent leg, all right, because it's right next to the 51. So that's what we're dealing with. Okay, hypotenuse and the adjacent leg. Which trig function is that? Okay, well, that's the cosine function. Involves the hypotenuse and the adjacent leg. So cosine of the angle is adjacent leg over hypotenuse. Okay, so cosine of the angle is equal to the adjacent leg, all right? And this time, instead of using a variable this time, I'm going to go ahead and just call it EF. Okay, so the adjacent leg over the hypotenuse, which is 18. Okay, so this is pretty much the same thing as like we did before. We can just multiply both sides by 18. Okay, so multiplying by 18 on both sides. Once again, those cancel out. Alright, this is getting in my way, so I'm going to erase it. So, you know, 18 cosine 51, that's going to equal EF. So 18 cosine 51. All right, so that's 11.33, got to round up. Okay, so that's 11.33 feet. Okay, so we just solved number 8. Alright, this video is a little long, but I'm going to go ahead and solve number 9 as well. Alright, especially because number 9, we're back to not having either angle. When you don't have the angle, you're going to wind up using the inverse trig functions to find the angles. Alright, that's what inverse trig functions are for, finding angles. Alright, just drill that into your brain. So, in fact, let me skip right to it because that's the main thing I want to teach you today. So, look, angle H. If I want to find angle H, okay, so angle H is right here. And we've got the 17 kilometers and we've got the 15 kilometers. Alright, so first you have to decide which trig function you're dealing with. Let's see. The 17, that's the hypotenuse. Alright, the 15, is this opposite or adjacent? Well, from the perspective of H, this is opposite. Okay, because it's across from. So opposite and adjacent. Which trig function involves the opposite leg? Did I just say adjacent? Opposite and hypotenuse. Which trig function involves the opposite leg and the hypotenuse? Okay, that's the sine function. Sine of the angle is the opposite leg over the hypotenuse. Okay, the sine function. So let's do that. Okay, so sine of the angle, all right, which we don't know, is equal to the opposite leg over the hypotenuse. So 15 over 17. So we set it up. If you want to find the angle, use the inverse trig function. So that means the angle will equal the inverse trig function, all right, the inverse sine of 15 over 17. Okay, so I can just use my calculator for this. Okay, so the inverse sine of 15 over 17. And we're supposed to round this to the nearest degree. So 61.9 is going to round to 62. Okay, so H is approximately 62 degrees. Okay, so that's crucial. That's how we use inverse trig functions to find angles. Now, to find the other angle, we're not going to use the inverse trig function. We could, but it's you know, if you're confident of your first angle there being 62 degrees, the easiest thing to do to find the other one is to just subtract from 90. So we'll just do 90 minus 62, and that's going to be 28 degrees. So angle I is going to be 28 degrees very quickly. Just subtract from 90. Alright, that just leaves GH. Okay, so we got to find GH. So GH is this guy right here. Okay, but let's just use the Pythagorean theorem. Okay, because look, we already have two sides given. If you have two sides given and you're looking for the third side, that's all about Pythagorean theorem. A squared plus b squared equals c squared. Okay, and that's what that's built for. So remember, the 17 is the hypotenuse, so that's going to be the one by itself. So I'm going to say x squared plus 15 squared is equal to 17 squared. Okay, this prevents me from having to use one of the angles I just found, especially since I had to round to find these. They're not exactly correct. So it's far better to use the Pythagorean theorem than to go back and try to use tangent, sine, or cosine. Alright, so do what I'm doing. So this is x squared plus 225 equals 289. Subtract 225 from both sides. Why do I keep wanting to put 255? Yeah, equals 64. And then of course we will take the square root of both sides. And that gives us x is equal to 8. Alright, so that means that HG was 8. Or GH. 8 kilometers. Let's put those units on there. Alright, so that's plenty for this video. We will have more practice on the next video. Okay? Guys, please make sure you're doing these problems by yourself. If you're having trouble and so now you're watching and learning, that's great. But don't just copy as I'm doing the problem. Go back and redo these problems by yourself to make sure that you can. And hopefully now that you've learned how to do it, go ahead and watch the next video. But first try to do these problems by yourself. Alright, and then watch the video and see if you were right or not. Okay, I will see you on the next video for number 10, 11, and 12.